My name is Börjeson. I'm the director of KBLab, which is part of the Swedish National Library. And we have produced a few language models. That's why I'm here. I plan to do this presentation together with Martin, our senior data scientist, but he is on sick leave today. He's going to be fine, but he wasn't really up for a presentation. We'll make do anyway. So why do KBLab and KB, the National Library, produce language models? Well, our instructions is to support Swedish research, and we have the data. We have the largest collections of edited text, Swedish texts. And that data can't really leave our premises as of now. So for Swedish research to have access to state-of-the-art language models, we need to produce them, for now at least. So basically, we're in it for the data. But this also means we have expertise at our lab within language technology, etc. But it also means that we need to be in constant sort of collaboration with others outside the library. So primarily RISE and the NLP group with Magnus, and also AI Sweden and the Swedish Language Bank at the Gothenburg University are our main sort of collaborators in our endeavors when it comes to language models. So we're in it for data, as I said. I'm just going to spend a few words on data here. So I would say data is actually a scarce resource. We don't have Swedish is not a small language, but it's not super large either. So given the size of the latest language models, we need to work hard to really get the corpora into size that will suffice to produce the really large models. So our library's collections are really, really vast. They're approximately 26 petabytes of data. However, it's a mess. They have been collected since the 17th century. So there are historical artifacts in the collections. Only a fraction of our data is digitized. So the most of our data is still in physical, locked into physical objects. And the main flow is still from physical to digital. So for example, when it comes to Swedish newspapers, and this is an effect of how the law is written, if you produce a newspaper, they send a copy to us, but they don't send the digital copy, they send the physical copy. So we need to digitize it. And this is slightly insane, which we have pointed out like many, many times. But it's still the sort of, it's what we're working with. And this has consequences. If you see this image of the Swedish newspaper Svenska Dagbladet to the right here, we have algorithms that are pretty good at identifying paragraphs, but they are still quite lousy when it comes to putting paragraphs together. So if you see the highlighted yellow text box on the top there, they belong together, but it's really hard to do this automatically. So we basically have tons of paragraphs, for example. So that's just one problem following this main flow, which is still from a physical object to a digital object. We cannot currently move data due to GDPR and copyright reasons. So we have to have computational resources co-located with data, and this is not optimal. It's not optimal because it's kind of weird that the library should have really powerful computational resources to build language models. They should perhaps be elsewhere. And it's not optimal because we want others, such as RISE, etc., to be able to build model on our data. And this is somewhat complicated. But we're working with this. So we will, in terms of infrastructure, we will be able to move this forward in the coming years. And then we have the sort of two valid but not 100% compatible perspectives of a national library, which is on the one hand storing data, collecting and storing data, and the time perspective when you do that. And this is the actual word that is used at the National Library, is that we store data forever. I don't believe in forever, but even if I only believe in 1,000 years, that is kind of different from the thing that we do at the lab, which is sort of using data. So for example, when it comes to digitizing books, the perspective of the library is that the books needs to be preserved for at least 1,000 years, both the physical object and the digital object. Whereas we, from the lab perspective, we only want to use the books to build corpora to put in our models. And these are somewhat colliding perspectives on the data. So it's not, because if this was not a national library, it would be much easier to sort of scale up and hurry on the digitization of the physical objects. But now we have to have all the time we have to think in terms of, okay, so if you make a digital object, we cannot harm the physical object. So for example, if you digitize a novel, we can't just cut off the back of the novel and do it real fast. We have to sort of do it in a very complicated, taking photos of each page, etc. And also the image caption has to be really, really good, because we want to do stuff with this digital object for at least 1,000 years onward. So this is why the digitization is not moving as fast as we want from a sort of using the data perspective. I just want you to have this background, because it sets the limits on everything we do, I think. And I will say even more about data. So given that, we're still trying to construct an assembly corpora from the library's collections. The first version we had for our first BERT was 20 gigabytes of cleaned and edited raw text. And I'm only talking about Swedish text here. And this was late modern Swedish from 45 and forward. And we used Wikipedia, governmental issued investigation, that's the SOUs, legal deposits, stuff that people are required to send in to us. They could be digital born newspapers, for example, social media, and OCR newspapers, which is the sort of large chunk of data. We have since then built a second corpus, which is 100 plus gigabyte of clean and edited raw text. That dates all the way back to our earliest newspapers collection, digitized newspapers collections, 1645. And we have added other media resources to that, some books. There's a paradoxical gap in our digitized collections when it comes to books. There's a whole story around that, but it goes back to the sort of differences in perspectives that I was talking about earlier. So we have very few books digitized. It's a bit strange, but that's how it is. But that's gonna change in the near future. So as you can see, the OCR newspapers in Corpus 2 is much larger corpus than in Corpus 1. Almost more than 90 gigabytes of OCR newspapers. And then we're working on a Corpus 3, which we hope will reach well beyond 1 terabyte. And it will be Corpus 2, and then we will add all newspapers. So all the newspapers from the smaller newspapers in Sweden. We will also, there's a National Library version of Common Crawl data, which is called Kultura 3, Cultural Heritage Free. We will harvest the text from that data. We have a large program now to digitize novels. We will make use of that. We can extract text from our audiovisual collections. We have well above 10 million hours of broadcasted Swedish, which we can use. And then there are more governmental text, etc., etc. Ephemera, that means commercial text, like from commercial leaflets, etc. Periodicals, that are journals like Time magazine. That was an English journal, but think of something similar in Swedish. And an extended social media corpus. So that will be a large corpus. And I hope we will have that, hopefully by the summer, an early version of that, but at least before the end of this year. And then we're also looking into creating a Scandinavian corpus together, because we want to, together with RISE and others, make a Scandinavian language model. We hope to do that. And that will be probably somewhere between 500 gigabyte and 1 terabyte clean and edited raw text in the Nordic languages. So that's how we're working with data right now, and a lot of our efforts is sort of directed toward this. And based on our data, we have made language models. We have KBBERT. I think it's still the Swedish model to beat in most aspects. I may be wrong, but it performs well. It was based on the Corpus 1 that was mentioned in the previous slide, and it was worthwhile building this model. It performs well, and it performs better than Google Multilingual. And an example of the performance accuracy in a downstream task named entity recognition, we can see that KBBERT performs very, very well. And once we had made the KBBERT, we had to have discussions with the NLU at RISE, Magnus and Ariel. Where should we go from here? You know, what's going to be the next model? And we decided to move forward after these discussions with an Electra based on Corpus 2. For KBBERT, there's a preprint. You can look it up if you're interested. There are some more sort of performance measures in there, etc. Why an Electra? Well, this has already been covered, I think, but the training algorithm is different. So instead of trying to guess the masked word, you're trying to discriminate between the original and generated tokens. So the main gain by switching this training object is that we make better use of data. So that the Electra models learn from all input tokens rather than just a small subset that is masked out, as is the case with BERT. So thus, turning to Electra, we sort of skip out of the general development of more and bigger, which is the sort of general development of language models, and trying to do something smarter instead, because Electra itself is not bigger than BERT, the actual model. And it has been shown that this, in terms of trade-off between sort of data and model size and training time and performance, Electra Small performs extremely well, and also Electra Base. Although some other larger models are argued perform better in absolute terms, but Electra, we believe that Electra should be really efficient in terms of how much training we have used to arrive at this model. So actually, I think I just got a text from Martin, though he is sick. He said that he has put up both the Electra Base and Electra Small on Hugging Face. So it's not in a few days, it's as of now. Oops, sorry. The documentation may follow the weeks to come, the full documentation. And we will be very happy to share basically everything except the original data. So the main question now, of course, when it comes to KBLab's Electra Base and Electra Small, are they any good? And the short answer is we don't know yet. And this, because we just finished them, and we haven't really had a good sit down, me, Robin, Martin, etc., the data scientists at the lab, to look at the model. The slightly longer answer is that training output looks very similar to what Google have. We have tested the Electra Base on one downstream task, the near named entities, and it does not really. It's close to KBBERT, but not on par. So it's slightly worse. It's better than BERT Multilingual, but it's not as good as KBBERT. And we're trying to think and reason about what the reasons are behind this. It could be that Electra is not as good as BERT when it comes to named entity recognition. It could be that the second corpus that we have built is more messy because it contains also older texts, and which could lead to a sort of a mismatch between the text that has gone into the model and the near training set, which is largely from Wikipedia, i.e. Later texts, contemporary Swedish only. Or it could be that the near training data set is subpar. And we're working with that too. We have a sort of an in-house crowdsourcing to elevate the quality of the near training data set, and we will follow that up with other training sets as well. But entities is a big thing in the library. We can have a seminar about that some other time, but we're interested in entities. and etc. There could be a gazillion reasons. So the sort of universe of things that you could modify is very, very large. And this is problematic since training this model takes a long time. So you really have to think twice before you modify something and retrain. And everyone is, of course, strongly encouraged to put the Electras to the test. And the larger NLP community efforts when it came to the BERT, KB-BERT, in testing, evaluating, and applying, etc., they are extremely valuable. So we really encourage everyone to just use them as much as possible and see how they can be applied and how it performs relative to BERT, etc. These are the training epochs, so the 2 million iterations, and it looks kind of like the stuff from Google. And this is where typically Martin would sit here and discuss these diagrams with you, but he's not here. So I'm not going to go into details here because I'm not really, I just got these numbers today actually. But the only thing I can say here is that it looks very much like the Google stuff, especially the end points. We end up in the same place as Google. It's a little bit shakier on the way there by the looks of it. We can maybe discuss that. I have a theory about that. And the question, of course, is where to next? Should we can't do everything we want to do. We don't have that kind of computational or personnel resources, actually. So we really have, together with AI Sweden and LRU at RISE and others also, need to have some really serious, I think, in-depth discussion on how to best use our pooled resources, both of brains but also on computational resources and data. And really large models in Swedish are within reach. I mean, we can have a corpus that are on par with what you have to train GPT-3. But is it really worthwhile, or should we put our effort somewhere else? So we could go for something larger, for example, an Electra Large, which is under training right now. It takes forever. Or we could go for a GPT-3 or T5, etc. Should we do a Scandinavian model? That's very high up on my list, at least. Should we do something more dedicated? So the library has very long texts. So it would be nice to have a model that is good in handling longer text with longer sequences from the sort of former family of language models. There's a model called Reformer, one is called Longformer, Linformer, Big Bird, etc. I cannot really relate to you any details about these models because I'm learning myself as we speak, not as we speak, but currently. Or should we go for something smaller, which is easier for most researchers, for example, to use, researchers that maybe not have access to large GPUs, etc. So that was my presentation.